All right, may I have your attention, please? Ladies and gentlemen. Our next talk is titled Putting 8 Million People on a Map, and our speaker is Blake Girardeau. Please give him a round of applause.
Good morning, or I guess it's good evening at this point. So good evening, everybody. I guess everybody can hear me well. My name is Blake Girardeau, and I am from the Humanitarian OpenStreetMap team. I'm the vice president of the organization, and the Humanitarian OpenStreetMap team we're really a bunch of OpenStreetMap mappers. And so we're OpenStreetMap mappers who have decided to focus on the humanitarian applications of OpenStreetMap. And so I'm here to tell you a little bit about what we do and the tools that we do, and I'm here to thank everybody in this room for making it possible, because it's all based on open source, and everybody who's helped build this open source community has made everything that we do possible. So thank you in the beginning, and I'll thank you at the end too, for sure. So imagine what it would be like if you lived in a town that had no map data. You could never look up where a doctor was. You could never look up where you had to go if you had to take your kids to the hospital. The city that you lived in, how would they plan for disasters? What would happen if a disaster hit your city and you had no map to figure out how you could get out for an evacuation route? Tens of millions of people live in places where there are no maps. Not just poor map data or something like that, but they literally are nowhere on a map. And so when they're struck by disaster, they face difficulties that we really can't imagine. So now what if you could fix that? What if you could go online and you could start to enter the information about your city, the things that were important to you? You could put your home on there. You could draw in the streets of your neighborhood. You could start marking landmarks and locations that were important to you. You could start dealing with infrastructure issues like power lines and radio towers and waste dumps and standing water and swamps. And what if 2 million people were doing it with you all around the world, and not only doing it for their towns, but doing it for towns around the world? And that's what OpenStreetMap is. OpenStreetMap is a worldwide collaborative effort to create a free and open online map of the entire world. It's open, it's editable, and the data that you create will be free forever for anybody to use. So the organization that I work for, most of you probably already know about OpenStreetMap, but the organization that I work for is called Humanitarian OpenStreetMap Team. And this talk is going to focus on OpenStreetMap's humanitarian applications and how we in particular do it. We create 3 open source tools that basically are the foundation of making it possible for millions of people around the world to come together and map places that don't have maps yet and help during emergency response and disaster preparedness. And this diagram that's up here is, I put this in here because this is what we call our napkin document. So about 10 or 11 years ago, when we were starting to think about this project called OpenStreetMap, from the very beginning it had always been envisioned that this would have humanitarian applications. And so this is literally the founder of our organization. When he was sitting down and jotting out how this would work, this is the document that he came up with. And you can sort of see, you can tell it's a little dated because there's no drones. There's satellites, there's airplanes, and at the time, kites. People used kites for aerial imagery and still do today. The other thing that the gentleman who created this document likes to remind us is that document everything, even when you think it doesn't matter, because 10 years later we can go back and look at the napkin that was the founding of our organization. And everything we do is based entirely on open source technologies. And when I was putting this slide together, I said, this is going to be great. I'm going to collect together all the open source packages that we rely on every single day, and I'm going to throw all those icons and graphics up on this slide. And it became clear pretty quickly that that just was not going to be possible. There's way too many open source packages that we rely on, way too many open source libraries that we rely on. It just wasn't going to be possible to get that on a slide in any reasonable way. So I kind of put the big ones up here. Most of OpenStreetMap is based on PostgreSQL, and then we use PostGIS that makes it geodata aware. Mapnik we use for rendering. We have products that we write in Node.js and Pylons and Django, and then there's a couple of editors up there. And then I even have one up there that makes no sense, and that's the ARPANET icon. And I only put that in there because, just to remind us that literally everything we do is based on open source software. We wouldn't even be able to begin to dream of a collaborative online map if the people who were developing the initial, what became the internet, weren't generating open source software that made it run. And that's the only thing that makes it possible for us to be here today. So, what does HOT do to make all this happen? And primarily what we do is training. So we do training and we mobilize volunteers. This picture is of a training that we were doing at a university in Indonesia. We primarily focus on what we refer to as the Global South, primarily because that's the place where there's no maps. The Global South suffers from the lack of any sort of map data, especially open and free map data. So if we're going to focus our efforts, we tend to focus on those areas because they're the people who are going to benefit the most. The people who do the mapping, the people who create the map data that we use for humanitarian relief work, they're generally mapping from home or from school, or more and increasingly they're mapping from work as part of mapathons. This is an informal mapathon at, it's called the Green School, and it's in Bali, Indonesia. And you can see it's just a matter of getting some people together with some laptops, do some training on OpenStreetMap, start to focus on some areas that are missing maps. And just again to give you a brief idea of what we do, this is, that is Freetown. That's Freetown in Sierra Leone. So this is from when we were mapping for the Ebola crisis. Again, there was just no map data. The vast majority of the population that they had to be concerned about, there were no references anywhere to those people, where they lived on maps or how to get there or anything along those lines. In a high density, 1 million people live in Freetown, and you can see they sort of are in the settlements sort of grow up informally. There's no street names, there's no house numbers, there's nothing like that. So the process that we go through when we're doing our mapping is we're looking at satellite imagery like this, and then we're tracing buildings. So this is what it looks like after somebody has done the mapping, and they've traced roads, they've traced buildings, and you can't really tell, but the yellow lines up there are fence lines, and we call this digitization. So we've just digitized this aerial imagery, and then when that's all over, we actually end up with vector data. And now this is data that we can plug into GIS systems. All the humanitarian organizations usually have a GIS department, so they can pull the data straight out of OpenStreetMap, or they can use one of our tools to get the data out of OpenStreetMap if they don't have a lot of skills in GIS. But once this data gets vectorized, now we can start to do things like population analysis, flood inundation analysis. You can start to figure out how many people you need to evacuate, where you can evacuate them to, and basically, have a much more effective response to whatever the disaster is that's going on. We don't only map remotely, although it's a large portion of what we do. We tend to map remotely and generate what we call base map, which is roads and buildings. And then we like to do field work, where we go into the locations if it's possible. So we map in response to crises, and that's almost all remote mapping. During a crisis, nobody has time to walk around with paper and pencil and write down exactly what's happening or where these buildings are. But we also try and map before there's a disaster. We tend to know where the floods are going to happen. We know where the cholera outbreaks generally tend to happen. We know where malaria is killing hundreds of thousands of people a year. So we want to get in there and we want to start doing this mapping before a major disaster happens. These three people are out, and they are, I think that's also Indonesia. The two people on the left and the right are using a product called Field Papers, and the gentleman in the middle looks like he's recording GPS points on his GPS unit that he can upload later. But the people with the paper have a printout of the aerial imagery, or they might have a printout of the vectorized data, it's hard to tell. But they're going to walk around their neighborhoods, they're going to walk around the city, And now they're going to start filling in all of the data that we couldn't fill in from aerial imagery. When I'm mapping from aerial imagery, I don't really have any idea what the buildings are used for. I don't know if it's a school. I don't know if it's a police station, a hospital, a pharmacy. I don't have any of that information. So this is where we go out and we train people who are local to the community in how to do OpenStreetMap mapping. And now they're walking around the streets collecting all of that information. Typically it's a partnership where we might have already base mapped for them, so they already have the building footprints and the roads. All they have to do is go around and take notes. The other big advantage that happens with this is we can start to get what we call administrative boundary data. A lot of what happens in countries that we work is based on what we, typically they might call it the ward level, you might call it like the neighborhood level or something along those lines, but that's also something that's impossible for us to map from the aerial imagery, and so that's also the kind of data that they collect when they're out there walking around. The first tool that I'm going to talk about is what we call our tasking manager. And this is really this is the heart and soul of what we do. This is what we use to organize thousands of people online and get them focused on the mapping that needs to be done. And so this tool takes you define a geographic area. In this case, it's another part of Indonesia. In this case, it's a part of Indonesia. And this tool, I define my area of interest, and then this tool breaks it up into work units so that people, wherever they are, all around the world, can check out one of these work units. They're typically about the size that you saw when I showed you the Freetown image. That's about a typical work unit. There might be 50 or 100 buildings in that work unit, and if you had a little bit of experience mapping, you can probably get it done in under an hour. The other thing this tool lets us do is it sets priority areas. That sort of large orange part in the middle is a priority area. In other words, we need base map for all of this, but if you could please start in this priority area, that's the place where it's been identified that we really need the information as fast as possible. You can see there's a lot of squares that are gray, which means that nobody has started mapping there. There are a fair number of squares that are orange, which means somebody has made a first pass. And so when we do our mapping, it's usually a two-step process. Somebody checks out a unit, does all the mapping, marks that they've mapped it, and then a second person comes along and checks out that same unit, reviews all the mapping that they've done, picks up any buildings that they've missed, maybe reviews the roads or the tracks or the paths that they've mapped in just to make sure that they're tagged right or whatever it is, polish it up a little bit if need be, and then mark it green as validated. And this is a pretty important step, and it's also one of the most challenging steps, but when you know that people are relying on this data to try and save lives, it makes a difference that we can give them a pretty high confidence level in the data that we're shipping them. So this tool letting us have at least two sets of eyes on everything and track what's been validated versus what hasn't kind of makes a big difference when we're shipping this data out and people are asking us, what's your confidence level in this? And if it's all green, I can say my confidence level is pretty high. And if it's all orange, I can say it's had a first pass. The other thing that this tasking manager lets us do is lets us sort of control what they're mapping so that we can get different sorts of mapping going on over the same area and not have to worry about conflicts. So I might very well set up a task that is approximately this size. I would make much larger squares, and then I might say this is only about roads. And then the people who are checking those task squares out, all they have to do is worry about tracing roads. Task squares this size are probably pretty good for buildings because buildings take a lot longer to map. But the point is we can have two sets of people working on exactly the same area with no worry about overlap and no worry about conflicts. This tool is written in Python, and it uses the pyramids framework. We also use SQL Alchemy for the database access, and there is a tool called GIS Alchemy that makes the SQL Alchemy aware of geo-related data. So, this is what happens. This is a town in Sierra Leone called Gwekadu. And Gwekadu is sort of turning out to be the epicenter of the Ebola epidemic that happened a few years ago. And so if you took a look at this town on the map, And this is an OpenStreetMap copy of it, but you can look on just about any map today. And you can look up Gwekadu, and you can see that it's going to look just about like this. And it looks like a medium to small-sized village as far as you could tell from the map data. This is actually a city of 250,000 people. So when I suggest that there's people who just are never on any maps, this is exactly what I'm talking about. There's 250,000 people in there at the epicenter of the Ebola epidemic, and there's no geographic data, there's no vector data that anybody can work with to start doing all the stuff you have to do when you're fighting Ebola. You need to go out to houses where people were sick, figure out who's in the houses around it. You need to be able to send out disinfection teams. You need to do all sorts of work. So this was one of the areas that we mapped as part of our Ebola response. And now you can see this is what Gwekadu looked like before, and this is what Gwekadu looked like after. And you can see now you can, yeah. Yeah, and it's impressive. It's also impressive when you look at the number of people who did this. This was 244 volunteers working on this project, and they mapped 90,000 buildings in 5 days, which is an amazing amount of work for such a few number of people. This is Mamau Guinea, also part of our Ebola project. This is another one where the emphasis, the important part for me when I look at this slide is this is 68 contributors. And you can sort of see as these units come in, you can kind of see how they match up with the squares that you saw in our tasking manager. And that's kind of a side effect of what happens when you're mapping in these grid units. But 20,000 buildings, 68 people, 29 hours. This was another pretty incredible mapping feat for us. We don't just map when there's a crisis either. So this is Dar es Salaam in Tanzania. And this was a much longer project. They have flooding problems. They also have problems with wastewater. There's a lot of open sewers. And so keeping track of where water goes, where water stands, and the best ways to start getting water out of the populated areas is a pretty important thing. This now is probably the best map of Dar es Salaam that's ever existed. We probably created the best map of West Africa that has ever existed in history as part of our mapping project, but this is for sure the best map of Dar es Salaam that has ever existed. It's worth it. This is a project that we did. Part of what we try and do is remote mappers do our base mapping for us, and they're what really make our project successful. But in every possible case, we want to go into the communities and build a mapping community there too. So this particular mapping project we went in and I think we spent 6 months training 160 university students in OpenStreetMap mapping. And then, like you saw in the earlier picture, they took field papers and they took GPS units and they took their phones and they went through the slums of Dar es Salaam, and then they mapped that for the next 6 months. And that's a pretty incredible project. They are called Ramani Huria, and now they're a standalone organization that works without us at all anymore. As a matter of fact, that same organization is now helping us map Mozambique, the neighboring country for them. So our tasking manager tool, the other function that it does is it breaks these things up into units that you have to map, and then it integrates with the actual editing tools that you can use to edit OpenStreetMap, and it'll turn that work unit over to the editing tools, which we don't write. So OpenStreetMap is a huge ecosystem of software packages that only exists because of the open source community and open data. We wouldn't have any of these tools to work with if it weren't for open source communities and the open data community. So these are two different tools. The tool in the upper part of this picture is the most advanced tool that you can use to edit OpenStreetMap, and it's called JASM, and it's a JASM-based application. It stands for Java OpenStreetMap. And this is it's one of the best applications I've ever used. It is almost a full-blown GIS application in itself, although that's not what it's intended to be. There are things that you can do in JASM that you can't do in some other GIS packages. But to me, it's the most intuitive application I've ever used. So once you get past the UI a little bit, there's some UI issues, but once you get past that, this app continually surprises me on the small things that the people who work on that also ran into, that I run into when I'm mapping, and they've done all kinds of tiny little things that make your mapping go much better. The tool that's shown in the lower part of this photo, this is our entry-level tool, and this is a browser-based application. It's written in JavaScript, and it's not quite as powerful as JASM, but you can do all the humanitarian mapping you want to do right in your web browser with this tool. This tool is called ID, the initials of the original developer. And this is what most people start on. If you want to start editing OpenStreetMap, the best way to start is jump into JASM, go through a 5-minute tutorial, and you know how to do humanitarian mapping, because it's just not that difficult. It's essentially drawing squares and lines. This gives you a little bit of a sense. This is the Sahel zone in Africa, which is sub-Saharan. Along the west, you can see we have a lot of projects. But these are what the footprints look like from our tasking manager. So all of this red that you see, a lot of them are collapsed because there's been so many, but all of this red you see was a project area at one point in time in our tasking manager. And so you can see we covered a fair amount of West Africa in detail. We've done some Central Africa in a little bit more detail, but you can also see that there's huge portions that are as yet unmapped. And if you don't see any red coverage on there, chances are they're not on the map. So there's a lot left to do. Thanks. It's not for me, it's for you. Thanks. The next tool that we work with, that we write as an open source tool, all of our tools are on GitHub, as are all of our website and a lot of our marketing materials and that sort of thing. But the next tool that we really rely on is what we call our export tool. Because humanitarian OpenStreetMap team, we wear a lot of hats. So we try and work with the crowd to get these things knocked out so that the people who are on the ground doing the responding have the map data that they need. At the same time, we are working with civic organizations and local governments and ad hoc relief groups, people with no GIS training whatsoever. So to try and make it much easier for them to use OpenStreetMap data, we write what we call our export tool. And this export tool is very easy to use. You draw a box over an area that you have an interest in, and then along the left-hand side, you can select what's important to you. So you might not be, or you might just not have bus stations and things like that, but you might be super concerned about pharmacies, clinics, aid stations, that sort of stuff. So you can get an export of the data out of OpenStreetMap. Just about anybody can get an export of this data out of OpenStreetMap, and then we can output it in a variety of formats. So we output it so it can go directly into a Garmin GPS device. We generally put those sorts of exports out when there's a disaster response, because disaster response people are showing up at the scene, and they can load their Garmin device with the best available map data, which is out of OpenStreetMap. And they can load it on their Android devices, and soon enough they'll be able to easily load it on their iOS-type devices. So just to kind of give you a sense, this is what it goes in. A lot of people, this is somebody who is, I can't quite remember. Oh, this is from Haiti. This is from Haiti in 2010, which was when our organization got founded. That was really the first application of collaborative mapping for disaster relief. And so this is exactly what's happening here. A gentleman has the latest image for Garmin devices, and there's a line of devices waiting for him to load that data on, and then they get handed out to relief workers. So there was an earthquake in Nepal last year, as I'm sure you heard, and this is a success story on a number of fronts. for us, because this story was, there was an earthquake, there was also an earthquake in Nepal in 2010. And one of my colleagues, Dr. Nama Budathaki, realized after that happened that they were hamstrung by the lack of map data available to them in that 2010 response. And so he decided that he wasn't going to let that happen again, that this was possible to do. People can get together and map. They've done it in Haiti. There's no reason that we can't get together and do this ahead of time for Nepal, because we know that there's going to be more earthquakes in Nepal. And so Nama set up what is called Kathmandu Living Labs in cooperation with the World Bank, who funded them for the first few years. And he got sort of a center for advanced technology going in Kathmandu. And one of their major focuses was mapping. So he spent years building his local mapping community, mapping the Kathmandu Valley. And then when the earthquake hit in 2015, almost the entire Kathmandu Valley had already been mapped by Nama and his OpenStreetMap mapping team. The nice part was, it wasn't the nice part, but part of the problem was they had only done the Kathmandu Valley, and we had mountainous regions that were equally affected by this. So this was an opportunity for them to use the data that they'd prepared in advance, so their Kathmandu Valley response had the data they need. It allowed us to do our remote mapping work in the more outlying regions and in the mountains. With that particular project, we had to just start with where people lived. That was the very first pass, was they were not sure where people actually lived when it came to some of these mountainous regions and parts that were not in the valley itself. So we did a first pass where all we did was find population centers, and we just circled them. And as soon as we got that done, we shipped that data out. And then we started doing additional passes where now we were doing roads. The other key part for this particular response was we also needed to find bridges and dams. Because after an earthquake, when the bridges go out, now you have logistics problems. And if you break a dam, now you've got to start worrying about what happens downstream. Did a landslide. The other thing that happens is a landslide will block a river. And now you'll have to worry about flooding, what happens when that river finally crests over that landslide. So Nama and his team got to work. They pulled out the data from OpenStreetMap. And this is a picture. It's kind of hard to tell. They're wearing two different kinds of fatigues. This is the Canadian Armed Forces and the Nepalese Army, along with two people from Nama's Kathmandu Living Labs, working with the map data that they had created for the Kathmandu Valley. And this is also, Canadian Armed Forces used all of our data, and this is what they passed out to all of their responders when they were flying people over to do the response work. And you can sort of see on the left-hand side, the data gets used in other ways besides just maps. 8,000 volunteers came together to help map during Nepal. It was by far our biggest response and probably one of our most successful responses. The third tool that we rely on is what we call Open Aerial Map, and this also came into play in Kathmandu in particular. So most of the remote mapping we do is going to be based on this aerial imagery. And aerial imagery, it depends on who you get it from, but it's usually a little bit aged, which works out okay in an earthquake situation because we sort of need to know what it looked like before the earthquake. But at the same time, we also need to know what it looks like right now. And so Open Aerial Map is the third tool that we've developed. This is a Node.js application, and it's designed to collect aerial imagery from drones, from whatever you're taking aerial imagery with, drones, balloons, kites, flying over aircraft, whatever it is. We can put it all into Open Aerial Map, and now Open Aerial Map can make that an index of that available to anybody who wants to find out where the best imagery is. They can find out when it was taken, what the resolution is. Its next phase will also make it federated so that you can be working with the data locally, and if and when you get a connection, it'll start to sync its data from what other people have contributed and from what you've contributed at your particular station. So drones were of huge use to us in a number of these things. Drones, this is Dar es Salaam again. And so these are 2 drones that were donated by SenseFly. These are called EB drones, and these are probably the top of the line drones that get used for imagery. And it's one of the places where we're still developing the open source tools to replace some of the proprietary tools. But these tools are amazing. And we trained, as I said, we trained 160 university students. And you can see, kids are fascinated by it, everybody's fascinated by it when you bring these drones out. And the drones are capturing imagery that just really isn't possible to get from satellites. We can get it in a much more timely fashion, and we can get it at a much higher resolution. For this slide says minimal cost. I would phrase that relatively minimal cost. These drones themselves are pretty expensive if you buy the off-the-shelf EBs. Granted, you're getting a top-of-the-line drone with, high-precision GPS ground stations for geo-rectification later, but they're still not inexpensive. But compared to paying for satellite time and paying for satellite imagery, way less expensive. And now the fact that these are in Dar es Salaam, they're now an asset for the Romani Huria people to use. They can drive around with their drones, and they can go to other villages and other cities, and they can run missions out, they can run flight missions out there, and then they can collect that drone imagery together. And then we pump it into Open Aerial Map. So now when somebody needs to map someplace that's not Dar es Salaam, they can look in Open Aerial Map, and they can see what sort of other imagery is available. And this is what Open Aerial Map looks like. It's kind of color-coded, so you can sort of tell the density of aerial imagery that's available for a particular area. This is not a live demonstration, but you can drill down into fairly small task squares, or not task squares, but fairly small units to figure out exactly which the best imagery is, even if you're in a very small localized area. And it gives you a preview of the imagery over there on the right-hand side. None of that is drone imagery. That all looks like Landsat imagery to me. But this is what this tool is about, cataloging imagery from whoever is collecting it. So that brings us to our 8 million people that we put on the map. And that 8 million people that we put on the map is through this project that we call Missing Maps. And the Missing Maps project was founded by my organization, Humanitarian OpenStreetMap Team, but it was also founded by the American Red Cross, the British Red Cross, MSF UK, and now we've added CART ONG and the Netherlands Red Cross and the Clinton Health Initiative. And this slide really talks about, why I do the work that I do. Because these are the organizations that are asking us to do this mapping. These are the organizations that fund us, and these are the organizations that fund our field projects to try and get these mapping skills out into the communities. I should have mentioned, the Red Crosses are now funding to the tune of around $500,000 in Gwekadu, the town that we mapped out, the 250,000 people. They're going to fund a center for mapping and GIS excellence in Gwekadu now. And they're going to build that out for 2 years. And then that's going to be a place where people can come and learn how to do mapping, learn how to use drones, learn how to use GIS software. It'll be a place for government officials and community leaders to come together. Those people will be able to go out and provide services to local governments and things like that. And it's all a part of this Missing Maps project, because these are the organizations that come to us and say, hey, look, OpenStreetMap is always the best data set when we show up. That's always true. They always turn to OpenStreetMap first. Primarily because we have the most data, but secondarily because the data is open and they don't ever have to worry about who to contact to get it or what the license is or any restrictions like that. They know they can show up at OpenStreetMap, they can do an extract of the data, and they can get to work. And then they contact us and they tell us where that data needs to be improved, or they tell us where that data is totally lacking because there just is no OpenStreetMap data for it. And then we start setting up our projects and our areas of interest to get the rest of that map filled out. So it was this Missing Maps project that it put the 8 million people on. Humanitarian OpenStreetMap team has probably put 10 million people on the map. But the Missing Maps project, for sure, we know have mapped areas that cover at least 8 million people. And this is just a heat map of where we do all our work. This is a combination of Humanitarian OpenStreetMap team and the Missing Maps project that we started last year. And you can see we've covered a lot of Africa and a lot of Indonesia and a lot of Southeast Asia, but there's a lot of places that aren't covered yet. So there's still a lot of work to do. This represents about 120 million map edits from 15,000 contributors and 1,000 projects on our tasking manager. And we've done it with surprisingly not as many people as you would think, right? So 8,500 people altogether have contributed to these projects over the years. And so our challenges next are to develop the tools and the outreach to get to more. 85,000, 850,000, 1 million people doing this humanitarian mapping. And that's it. I'm here to just thank you. None of this is possible without you. One second. I just want you guys to get this. None of this is possible without the open source community. It doesn't matter what package you've contributed to, how you contribute, documentation, UI, whatever it is you do, building the open source community makes applications like this possible. And it just wouldn't be possible if it weren't for everybody in this room and everybody around the world who supports open source software and open source tools. So, thank you.
All right, are there any questions?
Are you interested in mapping of historical events?
You know, that's a good question. OpenStreetMap in general, we are built on the OpenStreetMap platform, and we are OpenStreetMap community members first and foremost. And so OpenStreetMap has a bit of a philosophy of mapping what's currently going on right now. What's the situation on the ground right now? We do map historical objects like ruins and castles and things like that, but there's another project called Open History Map. I think it's called Open History Map. It just gets way more complicated when we start having to worry about when we add the next dimension of time. It's a challenge for us too, because we map damaged areas and we map internally displaced persons camps. And so we have to work on life cycle of that data to go back and review it and see if it's still an IDP camp or see if it's been rebuilt. So it's a challenge for us because that's often what we get asked to map is damage areas, IDP camps. So it comes up pretty often, but it's awfully hard for us to do. And OpenStreetMap in general is much more focused on what it's like on the ground right now. Yeah, that's a good question.
Have you thought about doing the very first pass, so not the validation, but the very first pass on the aerial data with a computer, with machine learning?
Yeah, we have. We've tried computer vision, and there are numerous university projects that like to try computer vision on this kind of mapping. And, you know, truthfully, it comes out at about the best I've ever seen that was done by a private company who I'm assuming spent a lot of money on doing it. The best that they could do was about 75% accuracy just on places where there's population. So they hadn't even attempted to do buildings and roads. They were just trying to figure out where buildings were in general. And it was still only about 75% accurate. And it broke down pretty bad once you got out into the extremely rural areas where it could not figure out, you know, these are farms, subsistence farms, so it's all spread out. You know, they could tweak their algorithms, but it just wasn't enough. It's certainly not high enough quality data for OpenStreetMap. OpenStreetMap wouldn't settle for something that was only 75% accurate. That would never fly. But we try, and we have a project, we're working with a group of university researchers right now to sort of do assisted computer vision, where you might click on a building and it would automatically do the edge detection and at least draw the square for you. Or you might click in the middle of the road and it can follow the road pretty well. But there's always going to be for OpenStreetMap, there's always going to be human eyes on it to confirm that it's right or wrong. So yeah, we'd love to do it. And this comes up, I work in an international working group of satellite-based emergency mappers, and this was a discussion in our spring meeting. And they all agreed that nobody had come up with anything yet that could replace what they did manually. Change detection on landslides, that they can get pretty good at. But like doing the actual detection on where the population centers are, especially when it's in the rural areas, we can do it faster with our eyes, you know, hitting squares and just circling where there's population. We can get much more accurate data that's useful than we can running it through a computer algorithm. But there's a role for that. We just have to figure out exactly how to fit them together so it evens out. I think you got to go to the other side of the room. Sorry.
Thank you. And one of the tools that you showed, the one embedded in the browser, we had like a Microsoft Bing search bar underneath. We just checked now and we didn't see it in the mobile version. But was it some sort of funding from Microsoft or?
Microsoft, for OpenStreetMap in general, Microsoft Bing, truthfully, I don't know who owns it at the moment. But when I started, Microsoft owned Bing, and they owned all their mapping and aerial imagery, and they made it available to OpenStreetMap for OpenStreetMap mappers to map from. So yeah, we benefit hugely from that donation. It would not be possible for us to do what we do if it weren't for Microsoft and Bing saying, you can digitize our imagery. Because the imagery providers get real touchy about digitizing their imagery. That's an asset for them, I guess, and so they're very, I don't know what, but they're a little bit touchy about us digitizing their imagery. But Bing, in cooperation with Digital Globe, who is where they get most of their satellite imagery from, those two organizations got together and said, OpenStreetMap, you can use all of our imagery and you can digitize it. So that's a huge boon for us. When we need to get imagery for a specific event, we need post-event imagery because we're looking for IDP camps and things like that. It's a negotiation process to get somebody to donate imagery. The imagery that we got from Digital Globe after Nepal, they estimated it being $5 million worth of digital imagery that they donated to us from their satellites. So it's pretty expensive. That's this relative cost with the drones, right? I could spend $30,000 with a drone and probably get some of the same area that was important, or I could spend, you know, $100,000 and get a few stripes from, you know, the WorldView 2 satellite. So yeah, so Bing, Microsoft enable a lot of this and turns into open free data. Will always be open and free. So we couldn't do what we do without them. So.
Any more questions?
So first of all, I think it's great what you're doing. One question came to my mind. That's when you map a certain area that wasn't mapped before, which might not be in case of an emergency, but just like the general ongoing work, I guess. Mm-hmm. Do you also talk to local schools to educate on maps? Because I've been as a tourist to certain areas where I would walk around with my Lonely Planet and a map in it, and I was like, well, where can I find this? And people would look at the map and they didn't understand anything. So do you know of such a project, or like maybe...
You mean to make so that local people can read the maps?
Yes, so they understand that dot on that map, that is actually their house.
Yeah, yeah, it's amazing, right? Yeah, that people, I mean, so yes, the short answer is yes. We love to go out into the communities and show them the maps that now have their houses on it, and show them that that's what it means, and show them that this is where your house is, and this is where your school is, and this is where your doctor is, and now you can see all those places together. Yeah, we absolutely have to do it. And then that sort of comes back to the rendering issue, where we can render these maps in different formats, print them. You know, we can print them out. That's what rendering means, printing. So we can print them out, and in theory, if we've done our job well enough, I can render a map that is much more easy for somebody who's not familiar with maps to read. This gentleman here did an amazing project in Managua, where they created the first transit map in Managua that Managua had ever had. 2 million people rely on public transportation every day in Managua. Nobody had managed to put together a transportation map until this gentleman and a group of OpenStreetMap mappers did it. And a big part of their project was, how can we design the printed version of this map for people who have never used a map before? And that was a quarter of the time they spent on their project, was getting that printout right, so that things that were significant to people in Managua, the way they had been navigating for so long without a map, you know, this little tree, that kind of reference was showing up on the map for them, so it would make sense when they started taking different bus lines that they'd never had access to before because they didn't know where they went. So yeah, it's a big part of what we do, teaching people and making them as accessible as possible. OpenStreetMap is UTF-8, so we can have names in any language, and you just, if I'm rendering it for somebody who speaks Swahili, I render it with the Swahili names. If I'm making the map for somebody who speaks English, I render it with the English names. That's the joy of OpenStreetMap, is it's multilingual. Every object can be named in any language, and then when you render it, you just pick the languages that are in who your audience is going to be. Yeah, that's a good question.
More questions? Over there.
We're getting close to time.
Hello.
Yes.
This seems like there's a big security issue, because like it is a perfect thing for military to have a semantic data on another sovereign country. So how does
Yeah, this comes up all the time. This comes up all the time in two contexts. So we're worried about humanitarian relief work. For example, the refugee crisis that's going on right now in Europe, right? So I'm worried about the mapping that I do, how that's going to make them more vulnerable or not. But then the other context is in straight military type security stuff. So whenever we're doing a project, if that's in any way, shape, or form a concern, we have to go to the local population, the local community, and they sort of decide what the best thing to do is. 9 times out of 10, the best thing to do is map, because a lot of these militaries already have this imagery, better imagery than I have. A lot of the militaries already have better maps than we have. They're just not public for anybody else to use but the military. So typically what happens, the only people who are suffering from the lack of the map data are the people on the ground, the community, the people who need the map data. The governments and other organizations that you might be worried about, they already have what they need to do whatever it is that they're going to do. And the same thing applies to, you know, it comes up with terror too, is how are we enabling terrorists? We're mapping the areas where Boko Haram has done terror attacks. And that's at the request of the humanitarian organizations who are trying to deal with the aftermath of what happens after Boko Haram attacks. They're intimately aware of what it means for us to create maps that could be used by Boko Haram. And their word to us was, Boko Haram doesn't care. They don't need these maps. They're going to do what they're going to do, and these maps will only help us get the message out about what's been done, and will only help us respond to the damage that these kinds of groups do. So it comes up all the time. We always defer to the people on the ground and to the local mapping community or the local civil authorities or the humanitarian organizations, and it almost always comes out that the map data is going to help way more than it can possibly hurt. So.
Okay, I'm afraid to have to end here. Please give our speaker a final round of applause.
Thank you all very much. Thank you for coming. Thank you for being a part of this. You're already a part of this. None of this happens without you and your contributions. So.